On August 20, 1977, the most ambitious space mission took off from Earth. The main goal of Voyager 2 was to study the outer solar system up close. It became possible because of a rare alignment of planets. Voyager 2 was supposed to study all the gas giants of the solar system – Jupiter, Saturn, Uranus, and Neptune. Astronomers also hoped it would be able to find and explore the edge of the solar system. Since Voyager 2 was built for interstellar travel, the probe was equipped with a large 12-foot wide antenna. It allowed the spaceship to send the data it gathered back to Earth. During its journey, the space probe discovered a 14th moon of Jupiter. Voyager 2 was the only spaceship to study all 4 giant planets from up close. It was the first human-made object to fly past Uranus, where it found 2 new rings and 10 new moons. Voyager 2 also flew by Neptune and noticed its great dark spot. That's a colossal spinning storm in the planet's southern hemisphere. The storm is the size of Earth and moves at a speed of 1,500 miles per hour. These winds are the strongest ever recorded on any planet of the solar system. In the history of space exploration, only 5 spacecraft have managed to leave the gravitational pull of the solar system. Those were Pioneer 10 and 11, Voyager 1 and 2, and New Horizons. People launch thousands of objects into space. These objects easily overcome Earth's gravity. But the Sun is around 300,000 times as massive as our home planet. That's why its gravitational pull is way more difficult to fight. Even more impressively, Voyager 2 is the second human-made object in history to reach the space between stars after passing through the heliosphere. That's a bubble of magnetic fields and particles produced by the Sun and protecting the solar system. 2 years after its launch, Voyager 2 started transmitting the first images of Jupiter. The space probe provided scientists with much-needed information about Io and Europa, some of the largest of Jupiter's moons. Then the space mission passed by the gas giant itself. The distance between the spacecraft and the planet was around 400,000 miles. That's when the probe noticed some changes in the shape and color of the Great Red Spot. It's an enormous, long-lived storm system, like a hurricane on Earth, but much, much larger. 2 years later, Voyager 2 reached Saturn. It discovered spokes and kinks in some of the planet's rings. While the spacecraft was flying behind and up past the gas giant, it passed through the plane of Saturn's rings. At that time, Voyager's speed was around 8 miles per second. For several minutes, the probe was hit by thousands of micron-sized grains of dust. This kept shifting the probe's direction, and its control jets had to fire many times to stabilize the vehicle. After Voyager 2 explored Uranus and Neptune, it headed out of the solar system. Its instruments were put in low power to save energy. In August 2007, the spacecraft passed the terminal shock. It's the boundary marking the outer limit of the Sun's influence. Here, the solar wind slows down. In the summer of 2013, the probe reached interstellar space. Now, when it comes to sending and receiving signals in space, there are 3 factors you should keep in mind: distance, power, and time. The farther away a spacecraft is, the farther a signal has to travel before it reaches it, and the longer it takes for this signal to catch up with the spacecraft. And when it finally gets there, it's extremely weak. Another problem is that once the spacecraft is launched, it can't be upgraded. It's literally stuck with the technology it was outfitted with. Plus, such spaceships as Voyager 2 are powered by radioactive fuel. When special material radioactively decays, it releases heat that gets converted into electricity. Unfortunately, the more material decays away, the less power the spacecraft has for receiving and transmitting radio signals. Despite this issue, we haven't lost the connection with Voyager 1 and 2. That's because new and more powerful technologies appear on Earth. Signals people send can reach much farther than before. That's why it was possible to stay in touch with Voyager 2, which entered interstellar space in 2018 and has already traveled almost 12 billion miles away from Earth. But in March 2020, the main piece of equipment that allowed scientists to exchange signals with the spaceship was switched off. After the communication with the spacecraft stopped, NASA spent around 11 months upgrading its deep space network and installing new hardware. The DSN is an international array of huge radio antennas that help astronomers on Earth communicate with interplanetary missions. These antennas are located in California, Madrid, and Canberra. The one used to keep in touch with Voyager 2 is a 230-foot wide dish in Canberra. This is the only equipment that can send commands that can reach the probe. This antenna, known as DSS-43, started operating in 1972, 5 years before Voyager 2 and 1 were launched. At that time, it was only 210 feet across. Since then, the dish has received a lot of repairs and upgrades, but these 11 months were the longest the antenna was offline. In October 2020, the antenna was finally ready for a trial after all the upgrades and repairs. The mission operators sent a set of commands to Voyager 2, and after many months of radio silence, the spacecraft returned the signal. The probe confirmed it had heard the call. After that, the spacecraft carried out the commands. While the dish was offline, the mission operators could actually receive scientific data and health updates from Voyager 2. Astronomers kept getting data from interstellar space, the region outside the Sun's heliosphere, but they couldn't send any commands to the probe since it had traveled too far away from Earth. The upgraded antenna received 2 new radio transmitters, and it was done just in time. One of the transmitters, that was used to communicate with Voyager 2, hadn't been replaced in almost 50 years. The antenna also got new cooling and heating equipment and other electronics necessary to support the advanced transmitters. Now, a curious thing about the Deep Space Network is that its radio antennas are positioned in a very precise way. They're spaced equally around the globe. This way, almost any spacecraft can stay in touch with at least one facility at all times. But Voyager 2 is an exception. In 1989, it made a close flyby of Triton, Neptune's moon. It was the only close encounter people had with the 8th planet of the solar system and its moon. By the way, Triton is the largest known object that is believed to be born in the Kuiper Belt. That's a donut-shaped ring around the Sun full of icy objects. Voyager 2 discovered Neptune's ring system and its tiny inner moons. The probe also gathered a lot of amazing information about Triton. For example, it became clear that the moon is covered in cryovolcanoes. Instead of spewing molten rock, these volcanoes spit ice consisting of water, ammonia, and methane. When the New Horizons spacecraft flew past Pluto more than 25 years later, it discovered the same phenomenon on the dwarf planet. Anyway, to make this detour, Voyager 2 had to travel over the gas giant's North Pole. But this changed the probe's trajectory, deflecting it southward relative to the planes of the planets. Since then, Voyager 2 has been moving in that direction. And now, the spacecraft is so far away that it's out of reach of the radio antennas in the Northern Hemisphere, those in Madrid and California. This makes DSS-43, which is located in the Southern Hemisphere, the only dish powerful enough in broadcasting just the right frequency to send commands to Voyager 2. Voyager 1, the probe's faster-traveling twin, didn't change its trajectory. After passing by Saturn, it took a different path. That's why now it can easily communicate with the 2 facilities in the Northern Hemisphere. The upgrade the Canberra Deep Space Communication Complex has gone through can also benefit other space missions. For example, the Mars Perseverance rover that landed on the Red Planet on February 18, 2021. The dish will also be crucial for exploring other planets and the Moon.
All the planets of the solar system are slowly lining up. Mercury, Venus, Earth, Mars, Jupiter, Saturn, and Neptune are about to form a straight line. This event, called the Parade of Planets, occurs once every 176 years. The last time this happened was almost 40 years ago, and it was a great chance to explore all these planets in one go. On August 20th, 1977, thousands of people gathered outside NASA's Kennedy Space Center. They came to witness the launch of the most ambitious and distant space mission in history. 5, 4, 3, 2, 1, ignition! Launch rocket Titan took off from Earth and left the atmosphere. As soon as the rocket reached outer space, it launched the probe Voyager 2, which began its journey. The probe consisted of a bus 1.5 feet in height and almost 6 feet wide. On top of it, there was a round 12-foot wide antenna. Most of the scientific equipment was mounted on a boom that extended 8 feet outward. On September 5, 1977, Voyager 1, the identical space probe, left our home planet. It sent us pictures of Earth and the Moon. It soon overtook Voyager 2, launched 2 weeks earlier. That's why the second probe has the number 1 in its name. And so the journey through dark space began. March 5th, 1979. About 4 Earth-Sun distances away from our planet, Voyager 1 came close to Jupiter and prepared its scientific equipment to explore the planet. The probe had a dozen gadgets, including a 2-camera system with narrow and wide-angle lenses. So, it could take full-length photos of the planet with the wide-angle camera, as well as close-up photos of specific places on the planet and its satellites. The probe also had a radio science system to determine the atmospheric composition, weight, and gravitational fields of the planets it came across. Infrared and ultraviolet spectrometers could help measure radiation and temperature invisible to the human eye. Various sensors were used to examine cosmic rays. Voyager 1 was the first to find volcanoes outside Earth. Those were on Jupiter's satellite, Io. It has dozens of active volcanoes that constantly spew lava. Then the probe pointed its cameras at the Great Red Spot. That's how people learned that it was a giant cyclone-like storm that hasn't stopped for the entire history of observations of Jupiter. It was also the first time when lightning was detected outside of our home planet. And in the invisible spectrum, Voyager 1 noticed that Io acted like an electrical generator for Jupiter. Ions, which are charged particles, were constantly flying toward the gas giant. This electrical current was 5 million amps. Soon, Voyager 1 continued its journey. 5 months later, Voyager 2 approached Jupiter too. This gas giant has rings around it. They're not like Saturn's though. Jupiter's rings consist mostly of dust. When the planet's rocky satellites collided, they turned into small debris. Gradually, this debris turned into fine dust. Then Voyager 2 approached Europa. This moon is completely covered by a crust of ice, and beneath it, there may be a liquid ocean where life can possibly exist. Voyager 2 was the first to capture the cracks in Europa's ice crust. While flying near Io, Voyager 2 discovered that 6 volcanoes on its surface were still erupting. This meant that the periods of activity of these volcanoes could last for months. Both space probes circled the gas giant several times and then dashed further into space. Such a gravitational maneuver allowed them to gain more speed and saved fuel for the trip. By November 9th, 1980, Voyager 1 had already traveled 8 Earth-Sun distances away from home. The space probe arrived at Saturn. It discovered 3 new satellites of the gas giant: Atlas, Prometheus, and Pandora. This proved the theory that these were the moons that kept the planet's rings in line. It also turned out that unlike Jupiter's, Saturn's rings also contained ice. Voyager 1 took a peek at Titan, Saturn's largest satellite. It's 50% larger than the Moon and even has an atmosphere. It's the only place in the solar system besides Earth where liquid water has been proven to exist. That's why scientists don't deny the possibility of life there. Then it was time for another gravity maneuver. Voyager 1 once again darted away from the planet's orbit. This time, it was aiming upward relative to the line of the parade of planets. Almost a year later, Voyager 2 arrived there. It made a flyby of several of Saturn's icy satellites. Supposedly, a long time ago, these moons collided and knocked huge chunks of ice and rock out of each other. This debris orbited Saturn, collided, and slowly crumbled into dust, consisting of ice and rock. This is how the famous rings of Saturn were born. Another gravity maneuver, and Voyager 2 set off for the next gas giant. 5 years later, it arrived at its destination, 17 Earth-Sun distances away from our planet. For the first time ever, a human-made object approached Uranus. Voyager 2 discovered 11 new moons there. The probe also found that Uranus was the coldest planet in the solar system. Its temperature is negative 350 degrees Fahrenheit. That's 4 times colder than the temperature at the South Pole. At that time, the Deep Space Network was being tested on Earth for the first time. It's a network of radio telescopes all over the planet. They aim at certain points in the sky to establish communication with extremely distant objects. These telescopes have been successfully receiving signals from Voyagers 1 and 2. August 25, 1989. Voyager 2 had already traveled 23 Earth-Sun distances and arrived at Neptune. It was the first time people received images of this blue planet from such a close distance. The probe discovered 6 new moons there. and also took the first pictures of the planet's rings. Engineers then turned off the probe's cameras to save power for its main computer and the instruments that measure the solar and interstellar wind. Voyager 2 left Neptune and headed into deep space. That's why it no longer needed the cameras. A few months later, Voyager 1 sent its last photo back to Earth. It was a family portrait of our entire solar system. Every pale dot was a planet. You can barely recognize Earth in the picture. After that, the camera was turned off to save power. This was the start of the interstellar mission for Voyager 1. For 15 years, Voyager 1 had been flying to the edge of the solar system. On December 16, 2004, the probe passed through the termination shock. This is where the solar wind suddenly slows down and heats up after colliding with the interstellar wind. The space probe managed to endure this test and continued its journey. In 2007, Voyager 2 crossed the same boundary. At that point, sensors recorded a temperature of about 266 degrees Fahrenheit, but the probe managed to withstand it and continued its journey through the dark cosmos. Both Voyagers moved through interstellar space in different directions. They discovered that the heliosphere, the solar wind bubble, is not perfectly round, but more like an egg. August 25, 2012. Voyager 1 became the first human-made object to enter interstellar space. It's now also the most distant artificial object in human history. On November 5, 2018, Voyager 2 also left the solar system. The two probes continued their journey into deep space. Right now, the Voyagers have been operational for 44 years. Voyager 1 has traveled 153 Earth-Sun distances and is moving forward at 38,000 miles per hour. In about 300 years, the probes will reach the Oort cloud. This is a hypothetical region around the solar system with nothing but asteroids and blocks of ice. Scientists believe they might reach the nearest stars in the next 40,000 years. Perhaps one day, the Voyagers will enter these star systems and explore unknown worlds. There may be planets there that look like ours. The probes may even be able to find an intelligent civilization there. For this purpose, each Voyager carries a golden record with a message on it. There are 115 images. Among them, there's our number systems, a map of the solar system and pictures of its planets, diagrams of human DNA, portraits of people, and landscapes from Earth. There's also greetings in 55 of Earth's languages, including the oldest and newest of them. There are also 90 minutes of music from every corner of our planet. The Voyagers also carry a device to play these sounds. If another civilization gets this record, their scientists could decode the data step by step. And then, that civilization may decide to pay us a friendly visit. They'll have to repeat the heroic journey of the Voyagers, though. Dozens of light years through dark space. Then crossing the border of the solar system, and finally flying past Neptune, Uranus, Saturn, Jupiter, Mars, and the asteroid belt toward the little blue planet. We can only hope that people will be advanced enough to welcome them.
On August 20th, 1977, the most ambitious space mission took off from Earth. The main goal of Voyager 2 was to study the outer solar system up close. It became possible because of a rare alignment of planets. Voyager 2 was supposed to study all the gas giants of the solar system: Jupiter, Saturn, Uranus, and Neptune. Astronomers also hoped it would be able to find and explore the edge of the solar system. Since Voyager 2 was built for interstellar travel, the probe was equipped with a large 12-foot wide antenna. It allowed the spaceship to send the data it gathered back to Earth. During its journey, the space probe discovered a 14th moon of Jupiter. Voyager 2 was the only spaceship to study all 4 giant planets from up close. It was the first human-made object to fly past Uranus, where it found 2 new rings and 10 new moons. Voyager 2 also flew by Neptune and noticed its great dark spot. That's a colossal spinning storm in the planet's southern hemisphere. The storm is the size of Earth and moves at a speed of 1,500 miles per hour. These winds are the strongest ever recorded on any planet of the solar system. In the history of space exploration, only 5 spacecraft have managed to leave the gravitational pull of the solar system. Those were Pioneer 10 and 11, Voyager 1 and 2, and New Horizons. People launch thousands of objects into space. These objects easily overcome Earth's gravity. but the Sun is around 300,000 times as massive as our home planet. That's why its gravitational pull is way more difficult to fight. Even more impressively, Voyager 2 is the second human-made object in history to reach the space between stars after passing through the heliosphere. That's a bubble of magnetic fields and particles produced by the Sun and protecting the solar system. 2 years after its launch, Voyager 2 started transmitting the first images of Jupiter. The space probe provided scientists with much-needed information about Io and Europa, some of the largest of Jupiter's moons. Then the space mission passed by the gas giant itself. The distance between the spacecraft and the planet was around 400,000 miles. That's when the probe noticed some changes in the shape and color of the Great Red Spot. It's an enormous, long-lived storm system, like a hurricane on Earth, but much, much larger. 2 years later, Voyager 2 reached Saturn. It discovered spokes and kinks in some of the planet's rings. While the spacecraft was flying behind and up past the gas giant, it passed through the plane of Saturn's rings. At that time, Voyager's speed was around 8 miles per second. For several minutes, the probe was hit by thousands of micron-sized grains of dust. This kept shifting the probe's direction, and its control jets had to fire many times to stabilize the vehicle. After Voyager 2 explored Uranus and Neptune, it headed out of the solar system. Its instruments were put in low power to save energy. In August 2007, the spacecraft passed the terminal shot. It's the boundary marking the outer limit of the Sun's influence. Here, the solar wind slows down. In the summer of 2013, the probe reached interstellar space. Now, when it comes to sending and receiving signals in space, there are 3 factors you should keep in mind: distance, power, and time. The farther away a spacecraft is, the farther a signal has to travel before it reaches it, and the longer it takes for this signal to catch up with the spacecraft. And when it finally gets there, it's extremely weak. Another problem is that once the spacecraft is launched, it can't be upgraded. It's literally stuck with the technology it was outfitted with. Plus, such spaceships as Voyager 2 are powered by radioactive fuel. When special material radioactively decays, it releases heat that gets converted into electricity. Unfortunately, the more material decays away, the less power the spacecraft has for receiving and transmitting radio signals. Despite this issue, we haven't lost the connection with Voyager 1 and 2. That's because new and more powerful technologies appear on Earth. Signals people send can reach much farther than before. That's why it was possible to stay in touch with Voyager 2, which entered interstellar space in 2018 and has already traveled almost 12 billion miles away from Earth. But in March 2020, the main piece of equipment that allowed scientists to exchange signals with the spaceship was switched off. After the communication with the spacecraft stopped, NASA spent around 11 months upgrading its deep space network and installing new hardware. The DSN is an international array of huge radio antennas that help astronomers on Earth communicate with interplanetary missions. These antennas are located in California, Madrid, and Canberra. The one used to keep in touch with Voyager 2 is a 230-foot wide dish in Canberra. This is the only equipment that can send commands that can reach the probe. This antenna, known as DSS-43, started operating in 1972, 5 years before Voyager 2 and 1 were launched. At that time, it was only 210 feet across. Since then, the dish has received a lot of repairs and upgrades, but these 11 months were the longest the antenna was offline. In October 2020, the antenna was finally ready for a trial after all the upgrades and repairs. The mission operators sent a set of commands to Voyager 2, and after many months of radio silence, the spacecraft returned the signal. The probe confirmed it had heard the call. After that, the spacecraft carried out the commands. While the dish was offline, the mission operators could actually receive scientific data and health updates from Voyager 2. Astronomers kept getting data from interstellar space, the region outside the Sun's heliosphere, but they couldn't send any commands to the probe since it had traveled too far away from Earth. The upgraded antenna received 2 new radio transmitters, and it was done just in time. One of the transmitters, that was used to communicate with Voyager 2, hadn't been replaced in almost 50 years. The antenna also got new cooling and heating equipment and other electronics necessary to support the advanced transmitters. Now, a curious thing about the Deep Space Network is that its radio antennas are positioned in a very precise way. They're spaced equally around the globe. This way, almost any spacecraft can stay in touch with at least one facility at all times. But Voyager 2 is an exception. In 1989, it made a close flyby of Triton, Neptune's moon. It was the only close encounter people had with the eighth planet of the solar system and its moon. By the way, Triton is the largest known object that is believed to be born in the Kuiper Belt. That's a donut-shaped ring around the Sun full of icy objects. Voyager 2 discovered Neptune's ring system and its tiny inner moons. The probe also gathered a lot of amazing information about Triton. For example, it became clear that the moon is covered in cryovolcanoes. Instead of spewing molten rock, these volcanoes spit ice consisting of water, ammonia, and methane. When the New Horizons spacecraft flew past Pluto more than 25 years later, it discovered the same phenomenon on the dwarf planet. Anyway, to make this detour, Voyager 2 had to travel over the gas giant's North Pole. But this changed the probe's trajectory, deflecting it southward relative to the planes of the planets. Since then, Voyager 2 has been moving in that direction. And now, the spacecraft is so far away that it's out of reach of the radio antennas in the Northern Hemisphere, those in Madrid and California. This makes DSS-43, which is located in the Southern Hemisphere, the only dish powerful enough and broadcasting just the right frequency to send commands to Voyager 2. Voyager 1, the probe's faster-traveling twin, didn't change its trajectory. After passing by Saturn, it took a different path. That's why now it can easily communicate with the two facilities in the Northern Hemisphere. The upgrade the Canberra Deep Space Communication Complex has gone through can also benefit other space missions. For example, the Mars Perseverance rover that landed on the Red Planet on February 18, 2021. The dish will also be crucial for exploring other planets and the Moon. Voyager 1, which has been traveling through interstellar space for more than 45 years and is trailing a long gray beard by this time, not really, it suddenly began to send strange signals to Earth. Even more bizarre, there are no signs that the probe has broken or anything. Scientists from NASA are desperately trying to find the reason. So, what's happened exactly? First of all, let me tell you a bit more about Voyager 1 and its long journey. Voyager 1 is an American space probe. Scientists from NASA sent it into space on September 5, 1977. Voyager's goal was to explore the outer planets of our solar system, namely Jupiter and Saturn. Initially, scientists assumed that the mission would take about 5 years. Haha, the joke's on them. The probe exceeded all expectations. Not only did it fulfill its mission, but it's still working for much longer than expected. Voyager 1 has been wandering around space for more than 45 years. It's hard to estimate what Voyager 1 has done for science. Firstly, it successfully sent a lot of photos of Jupiter and Saturn to Earth. By the way, you can even check out these photos yourself. All of them are published on the NASA website. Thanks to Voyager, we also discovered several new moons of Jupiter and a previously unknown system of its rings. We learned that Jupiter's famous red spot is actually a giant superfast storm. And after leaving Neptune's orbit behind, Voyager also sent a lot of important data about interstellar plasma. So Voyager 1 successfully proved to scientists how useful it was. After that, it happily headed for its next goal, the Kuiper Belt and the heliosphere. The Kuiper Belt is a ring of icy bodies that extends from Neptune to a distance of approximately 50 AU from the Sun. It's kind of similar to the asteroid belt, but about 20 times wider and 100 times heavier. And the heliosphere is an area around the Sun where the pressure of the solar wind is balanced with the pressure of interstellar gas. Yeah, I know, it sounds like some hard scientific stuff. Just keep in mind that this data really helps us understand the universe as a whole. So, this is Voyager's last task, to tell us more about interstellar space. The probe has already sent us more than 60 frames for a mosaic of the solar system from a distance of over 4 billion miles from Earth. Scientists use these frames to make a big colored picture. The photo was called the pale blue dot, and you've probably already guessed what that dot is. Yep, that's what our Earth looks like through Voyager's eyes. This photo clearly shows how tiny we really are. and how precious and fragile our planet is. But Voyager 1 also has another, even more important mission: to tell other civilizations about us humans. You might have heard about the famous Voyager Golden Records. People created many audio and video files and added them to these records. There are a few sections. The first one contains hello in 55 languages, including ancient and extinct ones. Almost 80% of the recordings are different musical pieces, like Bach, Beethoven, Mozart, and Stravinsky, folk music from different countries and ages, and a bit of the blues, like famous songs by Louis Armstrong and Chuck Berry. The remaining 20% of the recordings contain different human voices, sounds of nature and animals, as well as 116 images encoded as audio signals. There's also recordings of speeches by Kurt Waldheim, a former UN Secretary General, and Jimmy Carter, a former US President. These are just some friendly messages. In addition to the records, scientists also packed a needle for playing them. Don't worry, they also left a simple drawing that showed how to use all this stuff and how to translate the sounds into pictures. They added Earth's coordinates, which they created using a pulsar map. It shows the position of the Sun in the Milky Way. The record was packed in an aluminum case and covered with gold to protect it against radiation and cosmic dust. Carrying this record, Voyager 1 set off on its long journey, and it has already traveled quite a distance, I'd say. Right now, Voyager 1 is 154 astronomical units away from us. That's about 14.5 billion miles. This makes it the most remote human-made object. Initially, this title belonged to the Pioneer 10 mission, but Voyager overtook it in 1998. What a bargain for NASA! It's way beyond its best-by date. Voyager 1 is actually so cool that it even overtook its twin brother, Voyager 2, which, by the way, had been sent into space 2 weeks earlier. Voyager 1 moves at a speed of 9.7 miles per second. That's 35,000 miles per hour. Even the fastest sports car in the world travels at a speed of only 305 miles per hour. So it's hard to imagine the speed of Voyager. Anyway, at the moment, Voyager is heading to the borders of the Oort cloud. That's the name of a hypothetical layer of icy objects surrounding the solar system. Astronomers haven't confirmed its existence yet, but they're almost sure it's there. After all, even black holes were only a theory not so long ago. Unfortunately, Voyager 1 won't return back to the solar system. It'll keep in touch with Earth at least until 2025. But eventually, we'll lose the connection with it for good. In 300 years, it'll reach the borders of the Oort cloud. And in 30,000 years, I won't be around then, it'll finally leave the solar system. And if nothing happens to it along the way, in another 10,000 years, Voyager 1 will approach red dwarf star Gliese 445 in the Giraffe constellation. In the future, the probe will probably keep wandering around the Milky Way galaxy. And now, let's finally discuss the mysterious signals part. So, what happened? Well, a rather unusual thing. NASA's Jet Propulsion Laboratory, which monitors and controls both Voyagers, reported this problem in May 2022. Our veteran spacecraft suddenly began sending strange data to Earth. The whole situation puzzles even engineers from NASA. Now, I bet you're thinking, come on, the thing just probably broke down or something. But the truth is that Voyager 1 is totally fine. It works as usual, receives and carries out commands from Earth, and collects and sends scientific data. But the readings of the AACS, which stands for Attitude and Articulation Control Subsystem, don't show what is actually happening to Voyager anymore. This system supports the orientation of the probe in space and helps it keep in touch with Earth. So, basically, the signals mean that the probe's orientation in space is messed up. But scientists claim this is not the case. They know that the source of the antenna signal remains in the same position relative to Earth as planned. The problem hasn't triggered any of the onboard fault protection systems. The probe hasn't even entered safe mode. So, what in the world, or universe, is going on? Suzanne Dodd, the head of the project, says that the problem is not actually that unexpected. After all, Voyager 1 is already 45 years old. The expert admits that what's happening to the probe remains a mystery to them. They don't know exactly where the incorrect data is coming from, and it's unclear how this will affect the operation of Voyager. She adds, though, that it's not that surprising, considering that the probe is in interstellar space. There's a very high level of radiation there. No spacecraft has ever reached that point before. Scientists from NASA say they'll keep closely monitoring the data coming from Voyager 1 until they figure out the problem. If they find it, the management team will try to fix it. Otherwise, the team will have to adapt to the new conditions. It might not be enough just to understand the problem, though. It takes as much as 20 hours and 33 minutes to receive the signal from Voyager, and it takes the same amount of time to respond to it. Well, at least the second spacecraft, Voyager 2, is totally fine, even though it's also currently in interstellar space at a distance of 12 billion miles from Earth. Anyway, we can only wait for news and hope that the problem will be resolved. I actually wonder how much longer can Voyager 1 last? Will it be able to fly to the borders of the Oort cloud in 300 years? What do you think? I'd like to hear your thoughts in the comments. For decades now, people have been dreaming of exploring space. And since the year 2000, there has indeed been a continuous presence of people in space. And recently, a new record has been set. Just a couple of weeks ago, there were 17 people from 5 different countries in Earth's orbit at the same time. The previous record was set in September 2021 during the privately funded Inspiration 4 mission. At that time, the number of people in orbit reached 14. So let's see. Just recently, 3 more people have arrived at China's Tiangong space station. There were 3 more astronauts aboard the same station, but they've been there since November 2022 and are supposed to return back to Earth in June. Then there are 7 people on board the International Space Station, and 4 more departed the ISS aboard SpaceX's Crew Dragon named Freedom. They successfully returned to Earth on the 30th of May 2023, leaving 13 people in orbit. Interestingly, the current record also includes the 600th person to get into Earth's orbit. Specialist Rayana Barnai from AX-2 mission became a space traveler number 600, as well as the first Saudi woman in space. But I've got something even more exciting to tell you. Oh my! The record for most people in space, and just not in Earth's orbit, was reset not so long ago too. But it lasted for a mere 5 minutes or so. But during this short period of time, there were 20 people off the planet. This record was set when 6 members of the Virgin Galactic Unity 25 Spaceship Two crew happened to be in space at the same time as 3 Chinese taikonauts living and working aboard Tiangong and 11 astronauts on board the International Space Station. Now, that's getting crowded. Well, the International Space Station has always hosted the majority of space travelers from Earth. But I bet there are some cool facts about this marvel of technological development you haven't heard yet. The ISS is the 3rd brightest object in the night sky, and the coolest thing? You can sign up for a special service and you'll get a text every time the ISS travels over your location and is visible with the unaided eye. I've seen it dozens of times myself, and it's very, very cool. Normally, you can see it between dusk and dawn, but be ready because the station is very fast. It moves at a speed of 5 miles per second and circles our planet every 90 minutes. The International Space Station is a true record breaker. It's the largest human-made object in space. It's 357 feet long from end to end, which is about the same length as a soccer field. It also weighs about 450 tons. 8 spacecraft can dock at the ISS at the same time. The working and living space of the station is bigger than a 6-bedroom house. Astronauts have 6 sleeping quarters, a gym, 2 bathrooms, and a beautiful 360-degree view from their special bay window. Now to the nitty-gritty. On the ISS, you wouldn't have to deal with lots of disgusting smells. There is a specially trained person who smells everything astronauts take with them in space. It's done to protect them from unpleasant odors. The thing is that you can't really air the room out there if you don't like how it smells inside. That's why NASA is very careful about what kinds of smells are allowed to pass through. You'd also have to get rid of your clothes instead of washing them after each use. To bring a mere 1 pound of load to the International Space Station costs up to $10,000. That's why it's easier to throw your clothes away when they get dirty than to waste water washing them. Now, while sleeping, you'd have exceptionally good airflow around you. Otherwise, the carbon dioxide you'd exhale would form a bubble around your head and you get oxygen deprived, and that's not good. Now, people often think that in space you experience zero gravity, hence the weightlessness astronauts feel on the International Space Station. But that's not exactly true. Gravity is one of the most important forces that exist in the universe. Thanks to it, the Moon can orbit Earth and the Sun doesn't float away from our home Milky Way galaxy. But astronauts on the ISS experience not full-fledged but microgravity, which means itsy-bitsy gravity. Earth's gravity on the space station is not only around 10 to 12% weaker than the gravity on the planet's surface, but astronauts are constantly in free fall. The spacecraft, the people inside, and all the objects aboard keep falling forward, not down, but around our planet, following a specific orbit. And since they're all falling together, the crew and the stuff inside seem to be floating. But our space exploration plans are much more ambitious than just orbiting our planet on board the ISS. We're planning to send a mission to the Moon and build a colony on Mars. Some experts claim that in the next 25 years, around 20,000 people are likely to leave Earth. But how many people would it take to colonize an entire star system? In 2002, anthropologist John Moore from the University of Florida stated that a spaceship with 150 passengers could leave Earth and set off on a several thousand years journey to another star system. And upon arrival, the descendants of the original crew could build settlements in a new world. That seems like a lot of work to me. Let's continue. The nearest star system, Proxima Centauri, is 4.2 light-years away from our home planet. Talking about space is just next door, but for us, it's so far that we would need to build a generational spaceship to get us there. But the question is how many people you'd need to send on such a mission to have enough genetic diversity. A new study disagrees with John Moore, claiming it must be way more than 150 people. According to a scientist from Portland State University, a spaceship traveling to such a distant world would have to carry at least 10,000 people. This number might secure the success of the mission. 40,000 people would be even better. Who knows what could happen to the travelers during such a challenging and unprecedented journey? At the moment, NASA isn't ready to send humans even to Mars, let alone a distant solar system. But a few private organizations are working on this project. They hope to make interstellar trips possible in the next century. They count on a huge increase in propulsion speed, which could potentially reduce the travel time between stars to a mere few hundred years. Researchers have built several simulations to figure out how many various scenarios could play out during such an interstellar mission, and they have come to the conclusion that the success of this mission would greatly depend on the size of the starting population. Genetic diversity would keep the travelers healthy. The larger the population is, the more diversity it has. And 150 people is definitely not enough to maintain genetic variations. Even a population of 500 people wouldn't be sufficient enough. At the same time, if we sent to another solar system 40,000 people, we'd be able to maintain 100% of the variation. Even 10,000 travelers would make the scenario relatively stable, which means that any number between 10 and 40,000 people would be a pretty safe bet. But of course, we wouldn't be able to send so many people in space in just one spaceship. We'd have to build many and spread people among them. These ships could be modular, able to dock together for trade and some social gatherings, for the genetic variety, I'm guessing. But they would travel separately, so that if some disaster struck one of them, the rest would remain unharmed. But to make interstellar travel possible, researchers and engineers will have to overcome loads of obstacles. We still need to increase propulsion speed, deal with the negative health effects of living in space, and invent self-sustaining systems providing air, water, and food. Or we could just decide to fix our own planet and stay home.
It was supposed to be an easy 8-day-long mission. 2 NASA astronauts couldn't even imagine they would get stranded in space for at least 9 months. Their task was to test a brand new spacecraft, Starliner. They were hoping to return it to Earth as soon as possible so engineers could check it out and send it on a new flight. But from the very start, it didn't go as planned for Butch Wilmore and Sunita Williams, experienced astronauts who had both been to the International Space Station before. They were supposed to depart on the 6th of May, 2024, but had to postpone departure for 1 month because of a leaky valve in the upper stage of their rocket. When they finally took off on the 5th of June, new problems started before they even got to the station. There were failures in some of their thrusters and, later, leaks in the gaseous helium. It's important because it keeps the thrusters pressurized. Boeing, who built the new spacecraft, and NASA focused on solving those problems and figured out it wasn't safe for the astronauts to fly back home on the Starliner. They didn't just leave them on the ISS, of course. NASA came up with a plan where Butch Wilmore and Sunita Williams would come back home on a SpaceX Crew Dragon spacecraft. It took off in September of the same year with 2 empty seats out of a total of 4. The only problem is that it wasn't supposed to come back until February 2025 at the earliest. In a press conference from the International Space Station, Wilmore and Williams admitted it was heartbreaking to watch their spacecraft depart without them, but they were trained to expect the unexpected. They keep receiving messages of support from Earth, and they aren't at all sad to spend more time in space, as they say it's their happy place. Mr. Wilmore gets up every day at 4:30 in the morning, and Miss Williams at 6:30. They do at least 2 hours of exercise at the space gym every day to reduce the loss of bone density. Another big problem is sleeping in space. The space station has 6 tiny sleep pods, each about the size of a phone booth. Inside, there's a sleeping bag, a little storage area for snacks and personal stuff, and even 2 laptops attached to the walls with bungee cords. The pods aren't completely soundproof, so astronauts sometimes wear headphones to listen to music or calming sounds from Earth to help them fall asleep. But here's the problem. There are more astronauts than sleep pods, so 3 astronauts have to find other places to sleep. One of them sleeps in a simple backup sleep chamber inside the European Space Agency's Columbus lab. Butch Wilmore is roughing it in just a sleeping bag inside the Japanese Space Agency's lab. When they planned this mission, Butch was only supposed to sleep like that for 8 days, which didn't sound that terrible. Another problem they had to deal with was that they didn't pack enough clothes for several months. So, astronauts had to savor what they brought for the first 2 months until a resupply vehicle delivered fresh outfits, along with hardware, fruits, and vegetables. The astronauts have a super packed schedule that's managed by a computer tablet. It tells them what tasks to do, when to take breaks, and even when to eat, all in 15-minute chunks. A little red line on the tablet moves through the day in real time, showing them if they're on track or running behind. At first, Butch and Williams were working on the Starliner spacecraft, testing all its systems like communications, life support, and power. Once they finished that checklist, they started helping the other crew members with science experiments and maintenance tasks. The best-case scenario is now a late March return, and if it actually happens, the Starliner crew will spend over 270 days in space. An average mission on the ISS lasts around 6 months, so it's already way longer, but not close to the record time. The current American record belongs to astronaut Frank Rubio, who stayed in space for 371 days in a row. He lived on the International Space Station from September 2022 to September 2023. When Frank first went to space, the plan was for him to stay there for about 6 months, but it didn't go as planned. In December 2022, a meteoroid, or maybe a piece of broken satellite junk, crashed into the spaceship that was supposed to bring him and his 2 crewmates home. The spaceship was damaged so badly that it wasn't safe to use anymore. The 2 astronauts who were on that spaceship also had to stay on the ISS with Frank for 6 extra months until another spaceship went to space and rescued them. During his mission, Frank Rubio zoomed around Earth about 5,936 times. Altogether, he traveled a distance of 157 million miles. It's like going to the moon and back 328 times. Frank also went on 3 spacewalks and spent 21 hours outside the space station. One of Frank's big jobs was to do scientific experiments. He studied how bacteria behave in space, where there's no gravity pulling things down like on Earth. But his favorite experiment was taking care of a tiny tomato plant and watching it grow. Frank admitted that being away from his family for so long was really hard, but it's not the only possible hardship on such an extended space stay. Space agencies have entire departments that study the effects of space on the human body. In one of the studies, called Twins, scientists compared 2 identical twin brothers, Scott Kelly and Mark Kelly. They're both astronauts, but for this study, Scott spent a year on the ISS and Mark stayed on Earth. By comparing them, scientists could figure out how space changed Scott's body compared to his twin. He said it took him at least 6 months to feel like his usual self again after coming back to Earth. Scientists noticed predictable weight loss and bone mass loss, but they didn't expect to see changes in his DNA. They found that his telomeres, which are like tiny protective caps at the ends of DNA strands, got longer while he was in space. But sometime after he got back, he had more short telomeres than before. It looks like the damage was permanent. It must have to do with radiation, which is one of the biggest dangers for astronauts who stay in space for a long time. It can damage DNA, and that can increase the risk of some really serious health problems. Astronauts need protection from radiation, not just while they're flying in space, but also if they live on the moon or Mars someday. Scientists are working hard to find ways to keep astronauts safe from this invisible danger. Every space agency has rules about how much radiation astronauts can safely handle during their careers. Another big problem astronauts face is bone demineralization. It happens because there's no gravity in space pulling on their bones like there is on Earth. Without that pressure, their bones start losing minerals like calcium, which makes them weaker. Astronauts can lose about 1 to 1.5% of their bone density every month they're in space. When calcium from the bones gets into the body's waste system, it can lead to kidney stones. Because of these changes, astronauts coming back from space need time to recover. Another challenge in space is how the body's fluids, like blood, behave. On Earth, gravity keeps most fluids lower in your body, but in space, they float upward. This extra fluid in the head can push on the eyes, which might change how astronauts see. Some even develop a condition that can make it hard to focus their eyes, and sometimes the changes in vision can be permanent. When astronauts who spend a longer time in space, like Williams and Wilmore, return to Earth, doctors keep a close eye on their health with regular checkups. Scientists expect that their condition is going to be like that of 6-month astronauts.
Hey, you know what would be pretty cool? Having a tiny helicopter on Mars that can buzz around and scan the environment from above. Taking pictures and looking for hidden extraterrestrial life on its own. At some point, somebody at NASA said something like this behind closed doors. Then they went and actually did it. Say hello to Ginny, one of the most significant scientific achievements since we first started exploring space. Back in 2020, NASA's Jet Propulsion Laboratory, or JPL, packed a tiny side project onto the Mars mission. It was called Ingenuity, a flying experiment meant to test if powered flight was even possible on another planet. Just proof of concept, a test demo. The real mission was to explore the surface of Mars with the rover called Perseverance. In 2021, this 6-wheeled robotic scientist about the size of a small SUV landed on Mars in a place called Jezero Crater. Scientists believe there was once a lake here about 3.5 billion years ago. That's important because where there's ancient water, there might have been ancient extraterrestrial life. Perseverance is basically a science lab on wheels. It can study rocks, drill into the surface, and stash samples in little sealed tubes for later. These samples are part of a long-term plan. NASA and ESA plan to bring them back to Earth in 2033 for more study. This could finally answer, has life ever existed outside Earth? Maybe samples won't give the definitive answer, but it's our best shot. Suddenly 2033 seems very far away. The rover has other instruments and testing tools that could greatly benefit future exploration of Mars. But the hero of this story is Ginny. They got the idea for this little chopper from drones here on Earth and thought it could fly around and scout for Perseverance. However, actually making it work on Mars sounds almost impossible. The first problem was the atmosphere. Mars has approximately only 1% of Earth's air pressure, which means there's barely anything to push against. On Earth, chopper blades bite into thick air to generate lift. Since there's basically no air on Mars, it's sort of like trying to swim in fog instead of water. Then there's gravity. Sure, it's only about 38% of Earth's, which helps a bit, but not nearly enough to offset the lack of air. To fly at all, the device would have to be feather light, with huge blades spinning like crazy, just to grab onto the thin air. Oh, and there's also the cold. At night, temperatures plunge to negative 130 degrees Fahrenheit, which is approximately the same as the coldest night ever recorded in Antarctica. That's enough to damage most electronics, and batteries hate the cold. So Ginny charged up during the day with a tiny solar panel, then used that power to keep warm through the freezing Martian night. Every day, scientists had to hope that their drone worth $80 million wouldn't land under a hill in a shadow, especially since it couldn't be controlled manually. Mars is so far away that signals can take up to 20 minutes to get there. Imagine playing a video game where your character has that kind of delay after you press a button. Ginny had to be fully autonomous. All these technological technicalities, and yet Ginny did not simply fly. What was first planned as a 30-day test trial with 5 flights ended up being a full-fledged support mission that lasted 3 years. So, how did engineers pull it off? First, they had to make Ginny as light as physically possible, only 4 pounds. That's lighter than my house cat, but somehow it still carried 2 cameras, a battery, a flight computer, a radio antenna, and even a heater. Everything had to be trimmed down or miniaturized. Then came the blades, Ginny's most important feature. On Earth, a small helicopter spins its blades between 400 and 500 RPM. But we explained why that wouldn't work on Mars. So, Ginny's 2 rotor blades had to spin 5 times faster, about 2,500 revolutions per minute. Each blade was about 2 feet long, made from carbon fiber. Light as a feather, but tough as nails. And instead of sitting side by side like on a drone, those blades were stacked on top of each other, spinning in opposite directions. That cancels out the twisting force you'd normally get from a single spinning blade. You know how helicopters have that tiny tail rotor in the back? They need that because when their main rotor on top spins to lift the chopper up, it also creates a twisting force called torque. That makes the entire vehicle want to spin in the opposite direction. Without some way to fight that, you'd end up doing donuts in the sky. However, Ginny couldn't have a tail rotor because it would add too much weight, take more power, and make things even more complicated. So, engineers created a workaround with 2 large blades stacked on top of each other, spinning in opposite directions, which prevented the drone from spinning out of control. As for controlling it, Ginny didn't have a full-blown AI, but it wasn't remote-controlled either. NASA uploaded flight plans from Earth, but once the drone took off, it flew itself using onboard sensors and code. Basically, like a really smart autopilot. To stay on course, it watched the ground with a downward-facing camera, kind of like tracking its own shadow as a guide. And finally, the result was seen in April 2021, when Ginny lifted off the Martian ground and hovered in place for just 39 seconds. It rose about 10 feet into the air, hovered a bit, spun around a little, and landed safely back on the red dirt. It was short and simple. One small step for a drone, but a huge one for humanity. For the next 3 years, the team responsible was testing the limits, flying Ginny further and further. From above, Ginny saw more than the rover could. The drone helped map the terrain, spotted risks like loose sand and sharp rocks, and even found shortcuts for Perseverance. It even saved the rover, so to speak, when its photos helped the team reroute the vehicle around a tricky dune. Ginny also made snapshots of interesting layered rocks, exactly the kind you'd need when you're searching for ancient life. Basically, once the drone spotted something weird or promising from above, Perseverance would roll over to check it out. And it worked way better than anyone expected. However, in January 2024, Ginny went missing. The drone was supposed to do a short hop, go up, hover, land, easy stuff. But after takeoff, NASA lost contact. For a while, no one knew what had happened, just silence. A few days later, NASA finally got a weak signal and pulled the flight data. Turns out, Ginny flew over a featureless terrain. See, it used its downward-facing camera to track movement, kind of like an optical mouse. No texture below meant nothing to lock onto. Mid-flight, the drone got disoriented, tilted, and during landing, one of its blades clipped the ground. NASA confirmed it. The rotor was damaged. It will never fly again. However, this is not a sad story. Even with broken wings, the robot is still useful. After Flight 72, NASA gave Ginny new software and a new job, staying powered on and quietly collecting daily data, possibly for the next 20 years. In a way, Ginny has gone from scout to ground-based observer. So, what happens next? Well, we wait for 2030 while we make more flying robots. The biggest one on the horizon is Dragonfly, a car-sized rotorcraft scheduled to launch in 2028 and land on Titan, one of Saturn's moons. Titan has a thick atmosphere and low gravity, a dream environment for a flying drone. Dragonfly will hop from one location to another, searching for life in that icy landscape. It's like Ginny's big cousin, but with nuclear power and a whole moon to explore. The Project Ingenuity's success is already inspiring NASA to design better Martian helicopters. Some of them could be equipped with grippers to pick up rock samples, or even join up with rovers for full-on search and collect operations. Thanks to Ginny, what started as a tech demo could one day evolve into a fleet of flying robots crisscrossing the red planet.